Good evening to everybody who is joining us from India, and good morning to the guys who are joining us from US. So, are you guys able to hear me? Great. Good evening, Akash. Good evening or morning, Pari, Prashant. Great. Oh, that's great. That if you are all able to hear me clearly. Hi, Sanjay. So, sure. So guys, it's sharp 8:01 p.m. India time, and as I can see, by the time I started and I just completed the sentence, almost 10 more participants have come. So let's just wait for a couple of more minutes before we just get started on this webinar of introduction to real-time analytics. When you talk about real-time analytics, typically we will say real-time big data analytics using Apache Storm. So I hope that's okay, right, with everybody? So the only thing is, since it's going to be an introductory thing, at least there should not be any, miss out. Great. Okay. So I think, let us get started. Yeah, people are still pouring in, but still, yes, definitely. Let's just get started. So as I can see some comments where people are saying, would you please introduce yourself? Definitely. Yes, Dashrath. I'm definitely going to do it. I'm just going to start it, now. So guys, a very warm welcome to this introductory webinar on introduction to, real-time analytics using Apache Storm. You would get more details about the course at the URL which is shown here, edureka.in/Apache Storm. It's one of the ongoing courses. So I was the first one who started, who took the first batch here for Apache Storm, and we are growing strong in that side. As this is the class, or this rather than class, I would say this is the session wherein it's kind of an open invitation to everybody, and there is there are people in large numbers, right? So of course it would not really be possible for me to answer each and every of your questions right away. I would try to still answer some of the questions which are like very common, being asked from many people. I would try my level best to that, but still definitely you will have some questions as and when I'm probably discussing some of the topics, or probably you might be having some sort of probably some fee structure related queries, or probably some schedule related queries, or some other queries, right? So for that you can drop your queries on our Twitter handle @edureka.in/ask_edureka, or even we have our Facebook handle as well. I'll share that details also with you, and wherein you can drop your queries. Our people are there to continuously watch it, post the session, and definitely you should expect your answers then and there. Now, before I get started on the objectives and what exactly are the plans for today's session, let me introduce myself. So my name is Vishal, full name Vishal Kumar, and I have around, I would say, more than 10 years of experience overall. Around last 4 years plus, probably. Yeah, it's completely into big data domain. In fact, more than 4 years now. I've just realized it now. So that's how it is. And when it comes to the big data technologies, so the experience is a mix of, so it just the journey started with Hadoop, as it starts with everybody, and at that point of time, of course, Hadoop was there definitely, but yes, it was not in this kind of mature state wherever it is there. And then slowly from batch analytics, then we started exploring a bit about the online analytics, and then the options started pouring in, right? You have multiple options, so not just Hadoop family, probably so we started exploring Cassandra, a bit about a bit about HBase, MongoDB and all, and then we started using some of the frameworks, of Storm being one of them, and of course other frameworks, probably there are some more courses will roll out about them, like Spark and all. So yes, I have typically the exposure on these platforms, and when it comes to the domain side exposure, so my primary exposure is towards the retail side and a bit on the banking side as well as on the healthcare side. So these are the three different domains in which I have primarily worked. Have worked a bit on some telecom clients as well. So yes, but that is again very insignificant as compared to the exposure in the other domains. So I think that's pretty much about me, and I would not really, though I'm tempted to, but I would not really be able to afford, to take the introduction of each and every of you. But still, it's my typical experience from, and yes, one more thing which I missed about me is I'm associated with Edureka since last almost more than 1.5 years now. And again, the journey started with our Hadoop courses, and then slowly and steadily it is now into the other courses as well. So now, enough about it. So yeah, I was talking about your introductions as well. So my typical experience is, it's always going to be a good mixture of the experiences ranging from probably as low as people just starting their careers, just out of their college, versus there are some people in the class or in this session who are having more than 20 years of experience as well. So let us just get started about the objectives of the session. So the objectives for this session is, we'll just get into the crux of the matter, which is the need for real-time analytics. So what exactly is the need for the real-time analytics? We'll talk about it. And when we just say that, so it's not just a need in a theoretical perspective. We'll be talking about some of the use cases, and these are some of the use cases which I have seen in some of the industries personally. I think 2 of them I have been personally involved also in them. So yes, we'll be discussing some of those use cases, and then that would just be the case of the use case discussion of real-time analytics. We are not going to talk about Storm or something about that point. Now, that's where we'll probably have a look of the same problem. Probably we'll take a step back. We'll see probably, there are some big data frameworks like Hadoop and all are available. Of course, so their shortcomings are there. That's why you are seeing the emergence of newer frameworks like Storm, Spark, and probably Esper also. So there are so many frameworks. So how exactly Storm comes in this situation, and for the rescuing part of it, right? So how exactly Storm is applicable in those use cases? Definitely, I'll try to touch base on those points. Of course, it would not be possible for me to go in complete details about them right now, but yes, we'll try to touch base on those parts. Then there is an interesting thing which is going on right now in the industry. So Storm was a separate project. Recently, it has been incubated in Apache. It is an incubator project right now at the Apache, and there are efforts which are going on to integrate it along with Hadoop. And when it comes to Hadoop, specifically Yarn. So how exactly you can integrate Storm with Yarn? Theoretically, yes, it is possible. when it comes to practical thing, there is a lot of development and a lot of exciting new things which are happening right now. So it's still in a WIP stage, but it is just a matter of probably, I don't know, probably it's a matter of few weeks or probably a few months when you'll see a properly fully integrated Storm and Yarn kind of a framework, wherein it would be like best of both of worlds, right? So Yarn providing it enormous scalable processing capability, as well as the reliable storage part itself. And when it comes to Storm, it will all be about real-time processing of the data which is residing in SGFS. So going to be quite interesting thing. But yes, still it is in WIP, but we'll still see that how exactly it is like with the new architecture of Yarn, or with the new architecture of Hadoop, how exactly it is fitting in. And last but not the least, it would be about the Storm architecture. So of course, a detailed analysis of this architecture, the roles and responsibilities of each and every component and all, of course they are going to be discussed in bit more details when the actual course is going to start, when actual probably I think it is going to be covered in module 2. But yes, nevertheless, again, at kind of 20,000 feet level, definitely we'll have a look of Storm architecture as well. And then it would be a bit of small quiz kind of thing. So this will definitely give you an idea about the flavor of the classes also which we have. So typically our classes are not going to be a monologue. Here it is a webinar. It is not a class which we are holding right now. So this is a broadcast wherein I'm speaking and you people are hearing. But our typical classes are quite interactive, wherein it is a dialogue rather than a monologue kind of a thing. That's where these things put Edureka apart. But yes, coming back, still we have tried our level best to keep it a kind of an interactive kind of a session. So definitely there would be a small quiz to kind of quickly recapitulate of whatever points which we would have covered over this duration of under 1 hour or so. So great. So let's just get started then. Okay, yeah, I was just talking about Facebook as well. So on Facebook, that /edureka.in, edureka.in, that's a place which is the homepage of Edureka, and you can put your post there as well. So we are available on Twitter as well as on Facebook, or even if you are having even if you are going to have the customer care number, definitely you can pour in your queries there also. So definitely those questions will be answered. Now let's just get started with the main agenda. So the point comes that what exactly is the need for the real-time analytics? So with this statement, there are a lot of assumptions which are like already in background. With this, I definitely assume that you know what exactly is analytics. And second, I definitely assume that you know that there are two kinds of typical analytics streams which go hand in hand, right? Depending upon what exactly is the business case which you have. So there is one thing which is called batch analytics. Batch analytics typically happens at a certain frequency. That certain frequency could be once in a month, once in a day, once every hour, or something like that. When it comes to the real-time processing, it's kind of your OLTP systems, wherein the analytics should happen on the real time, as in when the transaction, or as in when an information or whatever piece of data in which you are interested, as in when it arrives, the analytics should happen immediately, right? So that is the real-time analytics. Now the point is how exactly real-time analytics becomes so important in various domains. There are I think these 4 cases which we have tried to put, and these are not some of the fancy use cases which you will typically see in some of the blogs and all. These are based on actual implementations of Storm which have already happened in production in different clients. I cannot really reveal the name of those clients because of I hope you understand it, right? Because of the business confidentiality reason, but still. Uh, uh, so these are the actual use cases of Storm which are actually working in production. So one is the case wherein in banking you have fraud transaction detection. Now this fraud transaction detection is something which I'm sure you would not have heard for the first time. Definitely you would have heard it many times, but when it comes to the real time analytics, how exactly does it happen? So see, the simple example is, let's say you have the credit card, right? Now if I'm not capturing, let's say, each and every data, whatever of transaction you're doing, then probably what exactly would be the kind of transaction, what exactly would be the kind of information which I might be capturing? Probably the customer ID, probably your credit card number, some of your credentials, the time when the transaction is happening, and the amount, and probably merchant IDs, and so on and so forth, right? So, and probably your maximum probably MAC terminal IP address or something, in case if it is being done via net, right? So these are some of the things which I would be doing it. But now how exactly the situation changes? Now with the big data thing coming into place, there are a whole lot of other things which can be captured, right? So probably not just this, some geolocations altogether, right? What exactly were the latitude and longitude of the place from where the transaction has originated, plus some other details. So for example, let's just try to see how exactly the scenario changes. So now you have, let's say, started capturing these two extra details, and you are doing a transaction. You find out that the transaction has originated from a specific credit card with a longitude and latitude of something XY, and there is absolutely no harm. Every transaction looks completely good. Within another half an hour, you see that there is another transaction which is originating from the same credit card. Everything looks good. Everything looks good. It is within the credit limits. No harms. The customer is proper, but the latitude and longitude information might be suggesting that one transaction which was done half an hour earlier probably was happening from, let's say, New Delhi. The other transaction within under half an hour is happening, let's say, from somewhere in Bangalore. Now, if you try to put geolocation along with the transaction information, which is, or the transaction actually you are capturing, the moment you try to combine these two, you can see there is a potential problem. Definitely there is something which is happening, some sort of phishing, probably kind of it might be a fraud transaction which might be happening, or for all that matter, it might be a valid transaction also. Probably your relative who is sitting in Bangalore, and you might have shared some of the details with your let's say relative in Bangalore. Probably they might be doing the transaction for you, but still, that the thing is, the transaction, when it is happening, system has to detect it, because now you are having extra data points with you, isn't it? Now the point is, it has to be a real time. So you cannot really raise the alarm that this transaction is fraud once the transaction is over, once you have updated your balances, right? Once you have updated your balances in the database, even if you detect this transaction, it does not matter. You cannot do anything, right? Because the transaction has happened, the money has been lost, right? So it would all be about who will be bearing the losses, just in case if it appears to be a fraud transaction. So something should happen immediately as and when the data comes to your servers, right? As and when data comes to your servers, and before even it goes to a business processing layer, right? Whatever, let's say your payment gateway, which does actual processing of your data, or probably a handler somewhere in between, right? Something should come in between, which should probably analyze this data, and as soon as it finds out some sort of activity, okay, this is happening, probably instead of straightforward going ahead and completing the transaction, you might like to refer it. You might like to, so there is a command, a process called referral. So you might be referring it to the call center, and I mean, that bank which has implemented it, it actually happens. So if you do these kind of transactions, immediately you will receive a call on your registered number from the bank saying that we are seeing a transaction so and so thing happening from this geolocation. Is it real?
or are you doing it? Or is your relative doing it? If yes, then good. If no, then immediately it is blocked. Isn't it an excellent example of real-time analytics? I hope you all would be able to, you know, correlate to it, isn't it, guys? So this is where, you know, you will find that the real-time analytics is required. Banking can be the best example of it. I mean, there is already a client which has put it in production along with Storm. So this is one example wherein people use it. The other example, I have more examples on banking side, but yes, let us keep it up to this point. Then on the telecom side, typically you talk about the, I'm not even going to talk about you know, day-to-day telecom activities. Let's talk about those guys who travel internationally, right? So recently there was a FIFA World Cup activity. You won't believe, apart from a sport activity, this was one of the gold mine activity for, or a gold mine event for all of the telecom companies, because there were a lot of international roamers who were, you know, who were at the same time in Brazil, and there was a huge amount of data which was being generated. Now, so there are several kind of transactions which happen, or there are several kind of analytics which happen on the data. Whatever, every call which you make, every time when you switch on your phone, you know, you generate a lot of noise data. When I talk about noise data, it is all about, you know, what exactly is your actual service provider, what is your geolocation, what exactly are the different operators which are providing you service there, out of which those operators, your actual home operator with whom they have the engagement of, you know, service level engagement and all. So based on that, revenue sharing happens. And the moment you switch on your phone, even if you are not using it, the other person who is, you know, you must be in the coverage area of some telecom operator, right? So they must be providing you some sort of service. Definitely they will charge it to the home guy, right? So now in this case, if I am an operator and I have to pay some money to the other operator who is providing the roaming services, definitely I would like to pay him, I would like to pay the other operator only if my users are using their services, only if I'm getting some revenue sharing. If I'm not getting any revenue sharing, why would I like to go and, you know, pay it to them? So there is a definition called silent roamers. These are the guys typically, you know, this definition changes from an operator to operator, from a continent to another continent, from a geographical location to another geographical location. So what is the definition of silent roamer in India might not really be the definition of silent roamer in US, or probably definition of a silent roamer in Africa would be completely different. So, but the whole point is, whatever your definition is, that is your business statement, but still, that has to happen on the real-time basis or as soon as possible kind of basis. So as in when, you know, your servers are generating data, this has to be analyzed. Now the whole idea behind it is, if I have to provide the bandwidth, if I have to provide the network services, I would like to keep the services to the guys who are using it already, who are either using it heavily or they are providing a medium uses. I would like to give my resources to those people rather than the people who are not even using it, right? That's a, you won't believe this, such a small detection results in several, I would say, millions of dollars of revenues every day. I'm talking at the everyday level. I'm not even talking at the, you know, yearly level or a kind of, you know, let's say monthly level kind of a thing. So this exactly is the case wherein, again, Storm, there is an operator which has already implemented it. There are other uses for Storm as well. There is something called roaming quality management and all. So I would not go in that direction, but yes, there are various use cases of Storm in telecom area. Retail, dynamic pricing. So dynamic pricing, I'm sure if there are some people from retail, definitely this idea is something which is not new, right? It's all about the principle of demand and supply. So depending upon how exactly your demand is and how exactly is your inventory, you can price your you know, inventory accordingly. If there is huge demand, and then you can probably try to price your you know, items a bit more to gain more profit, and if it is, the demand is still lesser, kind of a thing, then you can try to combine it and probably kind of sell it. The more dynamically it happens, the better it is, right? So typically there are some batches and all which typically run, so there was a retailer for which we had applied it, and they were earlier kind of doing it twice a day kind of thing, but when we started applying Storm, they were like every 5 minutes they were refreshing their rates. So that was another advantage which which you can directly see in the retail area, right? Social networking. So this is the simplest example, and the example which will take least of my time, right? Trending topics, nothing new, right? Talk about Twitter, talk about Facebook and all. You can actually see those things, right? Trending articles, trending news, trending topics, right? So, or those guys for whom maximum retweets have happened, right? So you can see that. Now so for what reason is this thing so critical? So this is very, very critical for the social networking sites to be relevant. And when I talk about to be relevant, because they thrive on user generated data, right? They do not thrive on their generated data. They are thriving on the user generated data itself. So it definitely has to be put in the most trending, the most popular data, or the most popular kind of material has to be shown to the users first. And also that immediately drives the revenues, that immediately drives the campaigns, the targeted ads, right? So all of them definitely, trending topics, trending articles and all, this kind of information is going to be very, very useful, a kind of gold mine of information for the social media or social networking companies altogether. And Storm has a role to play there as well. Okay, I got a point from there is a guy Sachin. He says he has lost the sound. He is not able to hear me, but I hope all of you others are able to hear me, right? Could you please confirm, guys? Sure. So Sachin, seems like there was some problem at your end. Sure. Thank you. So I hope you got some idea about it, that Storm and so again you will see in some coming more slides that Storm is not only thing in the market, or it is not really it is not just that okay, this is a single point solution for you, but yes, it has got several advantages over its competitors. So you will see that. But yes, this is something which is not an academic topic. Definitely it has got its industrial use cases altogether. That was the whole point which I was trying to bring. Now this is if I told you about that, if I told you about Storm and its use cases in the industry, this exactly is the slide which will testify it, which will be a kind of a testimony of whatever I said. And these are the graphs which are not from us. These are straight out of the Google Analytics. So basically Apache Storm as a search term, you can see up to January 2011, 12, there was some activity, but it was not so high. But from January 2013, and now you can see it's kind of exponential kind of a growth which has happened over the period of time. So last, I would say, last 6 months, or probably now going to be almost 1 year, the community for Storm has become very, very active. It was active earlier as well, but it was a standalone project. But now that Apache has taken it into the incubation, of course, the moment a project becomes an incubated project at Apache, definitely the activity level goes up. Also, the interest level also goes up very, very high. The other reason for this spike is it is not a marketing gimmick. It is all about that Apache, since Apache has taken it, all those descendants, right? Be it Cloudera, be it Hortonworks, right? I would not talk about the other frameworks, but at least these two which are very, very popular, they have started putting Storm into their integrated environment itself. So you talk about CDH4, I feel that CDH4 point something onwards, I don't really recall the actual version. Storm comes integrated in Hadoop, in HDP. I think HDP 2.1 onwards, they have integrated Storm, but yet Yarn and Storm integration is yet to be fully functional. So definitely these are various factors which have generated a lot of interest in basically in Storm itself. So there are some questions wherein people are saying that what exactly is y-axis? Y-axis is all about the number of queries. So this was a big number due to which we have not shown it, right? So there were some queries like growing e-commerce market also influenced by Apache Storm. Oh yes, by all means. By all means, you will see that in some of the customers. So Virendra, I think y-axis explanation, probably you have got the explanation, right? Great. Now moving to the next slide. Yeah, use cases. But rather than talking about the use cases, I mean, these are the, talk about the brands. Talk about the brands, Uyala, all of the video streaming, I would say almost probably 50% or more than that market share of various video streaming players who are there, Star Cricket, ESPN, Cricket Info, YouTube, and there are several others. They use Uyala services, at the backend. Flipboard, Logly, Vigo, Cerner, Twitter, talk about it. You'll be seeing that they are using, they are the guys who have published the white papers themselves, saying that how exactly they are using it. And in fact, you can see the source, right? GitHub.com. I would encourage you, Nathan March, who is the inventor of Storm. So that you can actually visit. I would highly recommend you guys to visit this page for more information. You'll get more idea about it, how exactly people are using it already in production. So these are the early adopters. Now, I would say it is not really possible for me to put kind of, let's say even 50% of those customers in one page, or probably even in 2 pages. There are so many, even in India as well, right? I know at least around 20 or 30, some small scale companies themselves who are using it. So that was quite surprising even for me. But yes, there is a industry-wide adoption already for Storm. Now, so with this, we have seen some of the use cases. Then we have seen a bit interest about Storm. We have definitely seen there is some sort of traction, and that those data speaks for itself, right? So with this, let's try to get a bit of understanding of what exactly is it? What exactly is Storm? So guys, Storm is actually a computation system. It is a computation system and it is open source. So it is basically it's a free and open source, and I would say distributed real-time computation system. So I hope some of you are aware of distributed computing systems like Hadoop and all. It is, people typically call Storm as the Hadoop for real time. Okay, this is actually, you can see the third point wherein it says Storm does for real-time processing what Hadoop did for batch processing. Though I would say Storm is definitely getting some stiff competition from other frameworks, like there is a framework called Esper. The problem for Esper is it doesn't really gel well with a huge amount of data. And then there is another framework which is coming up very, very aggressively, that is called Spark. So only time would tell, but yes, there are companies like Uyala and all, wherein both of these implementations are coexisting as well. So yes, no doubt about it. Definitely, Storm is called kind of real, kind of real-time Hadoop kind of thing. And the good thing is, so Storm works with the streams of data. Now, if you people are aware, or if you people even are not aware, I would like to kind of just recap a bit that when it comes to Hadoop batch processing, the idea there is data locality. The idea there is that your data is residing in some of the machines, and you typically send your code to those machines to get executed, and then you get the results out of those computations. And since it is data local and parallel, you are going to get your results very, very fast. But still, when it comes to very, very fast, the order is several minutes, probably 30 minutes or 40 minutes kind of a thing. But when it comes to Storm, it works on the stream of data. Here, the ideology is your data is flowing like in a pipe kind of a thing. It is just continuously flowing, and the programs are running on nodes continuously. So once you submit your topology, you will see that there is something called topology. It's like your entire, you typically create your jars and all. So typically you will submit your topology and it will run forever until unless you go ahead and kill it. Whereas in Hadoop and all, or in other systems also, when you submit your program, it executes and then gets completed. But here, your programs keep running forever. So the whole idea is your stream of data will keep flowing in. Your programs will run in continuum. As soon as they get some data, if there is any data which is of any interest, they will process it. Otherwise, it would just be discarded. Right? The other thing is Storm is polyglot. When I talk about polyglot, it is about supporting multiple programming languages. So typically in our class, in our course, we take only Java examples, but I have seen examples of Python Storm programs. I've seen some examples of Clojure. So by the way, Storm is typically, maximum of its portion is written in Clojure, and a bit of it is written in Python. That's the typical internal technology stack of Storm. But when it comes to the programs, as of now, at least I have seen 3 languages. I have seen Java, which we cover in our case. I have seen Python, and I have seen some programs of Clojure as well. So these are the 3 languages at least I have seen. There might be many more as well. Now, I'll move to the next slide. So we are going to discuss a bit understanding of Storm architecture. Again, this is going to be at a very, very high level, of course. But yes, still, it's all about what exactly are the different kind of actors in the architecture, and what exactly are the kind of roles which they play. Okay, though you can see that it is covered in module 2 in the course, wherein we tell this in bit more detail, wherein we first install it, and at that point of time when we are doing a bit of configuration of each and every some of the configuration files of Storm, when we do them at that point of time, many of these things even become clearer. But still, when it comes to the different actors in your Storm architecture, the kind of master for entire Storm is Nimbus. So there is going to be a node, there is going to be a machine in which this master process is going to run, and this process is called Nimbus. Okay, now this is the guy which is the master, which is responsible for submitting your jobs to the cluster, and that's it. So this guy is responsible for submitting your jobs to the cluster. Now, Zookeeper is a kind of a distributed coordination service. Of course, Zookeeper also has to be installed along with Storm. If your Zookeeper instance is not yet started, your Nimbus processes, or your Storm processes themselves will not start. They will start giving you some errors. If some people who are from Hadoop background could recall that HBase also, there is a guy called HBase, there is a different component called HBase which uses Zookeeper. So if somebody has that old experience of HBase, you would recall that earlier Zookeeper used to be a separate installation, and HBase used to be a different installation, and then from the later releases, Zookeeper started coming in inbuilt with HBase. So I think probably that stage is not yet reached with Storm, but probably in future you could see that Zookeeper is Zookeeper comes embedded. As of now, you have to install Zookeeper separately, and your Storm software separately. Now, so Zookeeper is something which basically takes care. So Nimbus has submitted it and that's all, but Zookeeper is the guy which is actually responsible for keeping it in the running stage. So your topology, what Nimbus submits to the cluster is the topology or the program which you write. Okay, that program gets submitted by the Nimbus, but then making sure that the program keeps running, and if there is a failure, so these supervisors are nothing but actual individual nodes wherever your topology is running. So you can just think of those supervisors and zookeepers or even Nimbus as different machines which are there in your cluster. Okay, so one of the machines which is a powerful one will be Nimbus. Zookeeper ideally will be installed on all of the machines, and there definitely there would be supervisors. So supervisors are nothing but again those machines. This is a different daemon. So all of your basically your Java programs are going to run inside JVM, so they are nothing but different Java JVM containers altogether, wherein your processes are running. So Zookeeper is going to be responsible to make sure that yes, your processes are running on each and every machine, and just in case if it, let's say, fails, then whatever data went into that has to be processed, has to be reprocessed. So that is something which you can control. There are something called reliable topologies, there are something called unreliable topologies and all, which you when you will go into the details of the course, when you will join it, you'll find it out. But yes, Zookeeper would be the guy which will be responsible for the continuum running of your topology altogether. Okay. Seems like some questions. So how to get data in Storm with queue, or are there any tool? So Subha, yes, you can get the data in Storm. There are various ways. You can probably be reading, let's say, from logs, or you might be reading it from a queue distributed queue kind of a system, let's say Kafka or 0MQ. There are several kind of queues, solutions through which it can be integrated. Or for all that matter, probably let's say you are going to put a Twitter API integration to your. It's going to be a simple Java program wherein you will be integrating it, and you might be getting the data. Okay. Can Storm use SDFS data? Definitely Storm can use SDFS data, but again, it's the point of can use. Is it using right now? No. That project is still WIV, Aditya. Okay. So does the Nimbus has the same limitation as a name node has in Hadoop version 1? Very good question from Dashrath. I would like to answer it in a bit more time, Dashrath. Okay, it's a very good question. In fact, I will have to come to this point. Okay, Zookeeper, both are the systems like data nodes. Exactly. So Naresh, be it supervisor, be it your Zookeeper or Nimbus, they are nothing but the different instances, different daemons which are running on a machine. Okay. Now, a bit more detail about those components and their responsibilities, though I have told them in detail, but still it's kind of recapitulation. So Storm cluster typically will be having three kinds of nodes. Okay, the first one is Nimbus node, Zookeeper node, supervisor node. When it comes to the Nimbus node, this guy is something which is responsible for uploading the computations. When I talk about uploading the computations, your topologies which you will create. So your program of Storm is typically called a topology. That is something which you submit, and this will always be submitted only and only from Nimbus. And of course, this Nimbus will be distributing the code across the cluster. It would be launching the workers also across the cluster. So supervisors and basically they are going to be your actual workers, wherein they are going to execute your processes. And also it monitors the computation and allocates the workers as and when it is needed. So what happens is, Now, this comes as a dotted line. So what happens is you have just submitted it, but then Zookeeper is something which is going to be continuously be monitoring your processes and all. But if there, in case there is some failure or something, it definitely that information is sent back to the Nimbus, and Nimbus will be the one which will be responsible to resubmit it. That's all. So this basically, as you can see, that Zookeeper nodes, they are just going to play the role of coordination among the Storm cluster. Your supervisor nodes, typically they are the actual workhorses, right? And they communicate back to the Nimbus only, again via Zookeeper only, and they are the one which are going to be responsible for the starting or stopping the worker processes which are responsible for the topology. So start signals, stop signals. So there are various kind of commands, wherein you can stop the topology, wherein you can deactivate a topology, wherein you can activate the topology, and probably you can increase the parallelism. So there are various kinds of signals or various kinds of changes which you can do for your topology once it is submitted via Nimbus. So again, those are some of the things which which again can be sent via Nimbus, and your supervisors would be the one which will be responsible to actually execute them. Now, this would be the place wherein there was a nice question which was asked to me earlier. I think it was by Dashrath, wherein he said that is the Nimbus going to have the same problem like your name node in Hadoop version 1? So if probably if there is somebody who is not from Hadoop background, probably you might not understand his question. So what he has said is, in Hadoop version 1, since there is only one name node, it is a kind of a single point of failure. If name node goes down, you cannot really interact with your Hadoop cluster. Everything is down. Your data is lost. Everything, unless you have a secondary name node kind of a thing. So here, do we have this problem? Looking at the architecture, apparently it looks like, but it is not. It is not. So what happens is, you have submitted a job, right? You have submitted basically a topology. It gets submitted to the cluster and it keeps running. Now your Nimbus goes down. So even if your Nimbus goes down, your cluster or your topologies are still going to run. They will not be affected. Only thing is, when Nimbus is down, but during the same time, still one of the processes also, if they go down, they would not be relaunched. They cannot be relaunched. That is for sure. But yes, the point is, if the Nimbus goes down, are the processes are going to be down? No. But in an unfortunate event wherein your Nimbus is down and as well as your processor also becomes down at the same time, it will not be relaunched till the time your Nimbus is up. I hope you get the answers, right? So definitely it is not a single point of failure for you. But yes, if it is down and then the failure occurs, then it is a problem. So it means there is nothing like passive node for Nimbus to restore it again. You can definitely do that. So there are various solutions on the top of it. That is like kind of redundancies and all. Definitely that can be done. Okay. Now, probably there was a question from, is Storm similar to Akka framework? Akka framework is completely different, Prashant. Okay, Akka framework is completely different. That typically works on the actors model from Scala. That inherits actors concepts from Scala itself. So it's a different ball game altogether. Okay, so I would not really go much into the detail of that. So that was a question from Prashant Kumar, by the way. What about how we are going to catch the results? So Dinesh, I think let me just complete some more slides on it. You will naturally get the answer of it, though at a very high level. Okay. So now that answer probably is right here. Okay, Dinesh. Okay. So this is the place wherein, let's say, we are going to see a different part. So that was from the architecture perspective. Now when it comes to you as a programmer perspective, what exactly are the different I would say parts of a program? So whenever you will write a topology, Okay, whenever you are going to write a topology, you are going to write spouts and bolts. Your spouts and bolts. Okay, so the typical thing is that your work, or when I talk about your work, it's all about your computations. Basically, they would be delegated to different types of components, or they would be deconstructed to different kinds of components which will be doing their specific task. And at the heart of it, there are two kinds of components. One is a spout, another one is a bolt. So the spout is the guy which is actually responsible for your data ingestion. Okay, so I think probably Subha Reddy or somebody else was asking this question, that how do we ingest the data? So I gave the answer that you can get the data from queues, you know, you have Kafka, you can probably, for that matter, invoke it from an API and all. Good, but what would be the place to invoke that that kind of logic? That would be the spout. Spout would be the place from where you would be doing the data ingestion, and this will be the whole sole purpose of a spout. Take the data, pass it on. Take the data, pass it on. Now there are much more details which are involved in this. Take the data, passing it on, good. That's the whole purpose of spout. But how to pass the data? Or is it to be a broadcast approach, or is it going to be a point-to-point approach? Or in passing the data, if the failure occurs, what should happen, what should not happen, right? Any of these things come, those are the details. These are definitely taken care in the, you know, in the entire Storm framework. There are kind of shuffle grouping, I mean basically the stream groupings which are possible, various combinations are possible, which depending upon your situation you can use them. Of course it is not really the right time to discuss about all that, but yes, it is definitely supported. So via spout, basically the data is passed on to bolts. Now these are the bolts which will be running on different machines, and typically your actual business logic, either it is kind of some sort of a transformation logic, or it is going to be some sort of a summation logic, aggregation kind of a logic, right? It is going to be written in bolts. Now the bolts can do some transformations, can do some sort of aggregations, or whatever you want them to do. They can do it, and then they can pass on the data further from one bolt to the other bolt, again using the same mechanism of of spouts. But yes, they can pass on the data, and then when it comes to the bolts, probably a bolt can be your endpoint as well as they can store the data. So as you can see here, your spouts are passing some data to the bolts, and then they are storing the data. One bolt is storing the data into a database, though it is a very rare thing. Let me tell, it is very rare that you would be storing the data into a database using a Storm kind of a framework. Typically, there are very less such kind of applications, because Storm lives in present. It does not care what happened in past. It does not care what will happen in future. It just works on right now, what is happening right now. So typically those kind of applications are, the best candidates for Storm. But still, if you want to do it from the capability perspective, yes, you can do it. Or the bolt itself might be the endpoint. So probably the whole sole purpose of a bolt might be, let's say, to get some data in a transformed manner and then check the data, and probably, let's say, just in case if there is, let's say, the same example, right? There was a fraud transaction kind of a thing. The moment it detected it, probably it will immediately redirect that data to an API, which will take care of the further action, right? In that case, the bolt, whatever is responsible for a kind of detection logic, is just doing a detection and probably just passing it on. Instead of passing it on to the payment gateway, it might just be redirecting it to some sort of referral system, right? So depending upon the kind of business logic, depending upon the kind of implementation, there might be various endpoints in your topology. Okay, so Spout is a part of Nimbus. Spout is a part of your entire Storm architecture, right, Prashant? So I hope, Dinesh, now you got much better answer, right? What about how are we going to cache the results? I hope so. Where this bolt is processed, is it in the supervisor? Yes. So be it the bolt, be it the spout, any of these things, they would be processed in the supervisors. It's about Nimbus. goes down and then it still runs. No other processes, how we are going to get the results later. Okay, so probably you're talking about the Nimbus goes down. So if your Nimbus goes down, your processes, so typically your data, whatever is passing from spouts and bolts, they are not affected. But just in case if the Nimbus goes down and your processes also go down, then the processes will not come up until and unless the Nimbus is up. But yes, for the failures there are some failure recovery mechanisms. It's all about there is something called reliable spouts, reliable bolts and all, wherein there are some message replay kind of mechanisms which are available, wherein you track whether a message is processed or not. So those kind of stateful transactions are possible. I hope you get the answer, right? Great. So this was, believe me, this is a very high level kind of a thing which I would say I've just explained. Okay. So can I assume that each bolt reside in each node? Yes. For the sake of simplicity, at this point of time, there's no harm. Okay. So now. So why exactly, then Storm is ideal for real-time processing? Now, I would like to say at this point of time, probably I hinted it at the start itself, that there are, there are various kind of players in the market. As I said, Storm is one, Spark is one, Esper is one. There is something called Samza. There are several others, right, which are kind of competitors of it. Now, some of the things make there are some of the things which make Storm really ideal for it. One of the main reasons is it is fast. Of course, it is, like you can see the benchmarking itself, right? It is processing around 1,000,100 bytes per message. So you can see how much data, and this much data can be processed per second per node, which is huge. It is scalable. So scalability part, definitely, even if let's say you are running it without Hadoop integration, you can create the cluster of Storm and your data can be processed across different worker nodes, as you can see that. But not only this, even Storm can, when it gets integrated, right now it is WIP, but once it gets integrated, you can see that the data, even if you have stored it, you have already persisted in HDFS, that also can be worked upon, in a parallel manner. Definitely. It is fault tolerant. I think it is just the same point. When the workers die, Storm is going to automatically restart them. And if the node dies, of course, worker will be started on the other node itself. Of course, this is how it works. But again, this will happen via Zookeeper. It is reliable. This is something which is the USP. So talk about Samza, talk about Spark and all. So they typically do not give you the guarantee of reliability. They are not reliable. Once a message is lost, then it is lost. But here, when it comes to Storm guarantees it. I mean, though that guarantee is in your hand, you want to take it, you want to overwrite it. Probably it depends upon the kind of application on which you are working. So if you are getting a lot of transactional data, losing even a single transaction causes a harm for you. But you are getting a lot of tweets, and out of 1 million tweets, if you are losing, let's say, some 10 tweets out of it, probably that doesn't really matter that much, right? That probably cannot really I would say alter the sentiments in a very critical manner. So that depends. But if you want those guarantees, definitely Storm provides those guarantees. It is quite easy to operate. I would say this is something which is I would say very rosy kind of term. I would be very clear about it. Yes, this is a relative term. If you are good with Java, if you are good with your admins are good with these daemons and all, yes, they can easily install it. Otherwise, there is a slight learning curve, definitely. But once you have deployed it, it is much easier to monitor as compared to, or even the configuration management and all are much easier as compared to Hadoop. So definitely, these are some of the, I would say, USPs of Storm. In fact, there is a nice article from Hortonworks. You can please refer that as well for your further reference. Now we can actually see that the slide which I'm going to show you now, which I'm actually is visible now, is something which is as of now sitting at the theoretical level. Okay, that project once it is over, probably entire world will know about it. So it's all about that with Yarn. So in Hadoop 1.0, you cannot integrate Yarn to Hadoop. Sorry, you cannot integrate Storm to Hadoop 1.0. It can only be integrated with Hadoop 2.0 because of the Yarn framework. Yarn is something which has taken, kind of cluster resource management and all up to a different level. Earlier, all of that was embedded using within the mapper itself. So that was the main reason due to which, you could not. But with the new architecture, just in case if you people are not aware of the architecture, please do not worry. Those people who are aware of the architecture can easily know that be it your Storm, be it Graph, or even Spark, or there are some of the Giraffe, and there are others also, Crunch, Drill. There are several other projects which can now take the advantage of Yarn. Okay, they can take the advantage of Yarn. So using this, basically you can plug in Storm along with the other components which can take the advantage of underlying HDFS data. So just in case if somebody is aware of Hadoop 2.0 thing, so in Yarn typically you have application master, and then you have resource managers, and then you have node managers and all. So the application master here, the plan is the application master is actually going to be your Yarn master, which will further spawn your node manager services, or node managers or Yarn child processes which are going to run are going to be those individual worker processes which are going to run on your cluster. So I would just leave it at this point of time, because if I have to go into depth, I can speak on this slide itself for another probably half an hour or 1 hour kind of thing. But anyway, so this is where I would say that touch base kind of thing goes away, because after this there would be a bit of quiz. So I would definitely encourage you guys to whatever we have talked about, right? Definitely that kind of interactive. Of course, I hope you have felt that it is. I've tried my level best though to keep it as interactive as possible. And please do not get disheartened if some of your queries are not answered, because of as you can see that a lot of queries are pouring in, but still there would be some sort of quizzes also immediately after this this slide. So the batches which are going to start, basically one is starting at 16th August, 8:30 p.m. to 11:30 p.m. India time, and the other batch which is going to start is from 13th September, which is from 7 a.m. to 10 a.m. India time. And the curriculum, okay, so this curriculum is quite interesting, I would say. So module 1, definitely we are going to talk about the introduction of big data in Storm. So so those people who are coming from this background of Hadoop and all, probably a bit of overlap might be seen at the introduction of big data, because there also we tell about the big data thing. But here we do not want to take chance, because there might be some people who are straightforward starting on Storm. So for them, introduction of big data, and as well as on the Storm thing. Module, so that I would say that is the probably that is the only session where it is going to be a bit theoretical. But right from module 2, when we say getting started with Storm, it's all about getting it installed, and at least in the first iteration, what we used to do is we used to set up the entire the development environment as well as the project environment. So there are real life projects which you are going to see in module 5 and module 6. For them also the setup, let's say we were doing a bit of node.js, and we were doing a bit of Redis setup and other stuff, that also we do it in the module 2 itself. So that all of that setup related activities and configuration related activities do happen in the module 2 itself. And then module 3 and module 4. Now spouts and bolts is something which I have told, which we'll see enough of the examples about spouts and bolts in module 3. we talk in bit more detail about them, all the shuffle streaming, some of the examples, concrete examples, and then we see running them. Therein we see that, you know, some of the hands-on and all, wherein let's say either we populate some data within the program, or sometimes we generate it from the streams, or sometimes we read it from the files, so and so things, right? So those are the things which you will see in module 3 and in module 4, which is about trident topologies. So trident topologies are typically, those people who are from Hadoop background can easily see that there is a pig, there is something called pig, right? Pig is a high-level abstraction. So similarly, in Storm world, there is something called trident. It is a high-level abstraction on the top of you know, spouts and bolts. Spouts and bolts, very good for programming, but again, you know, we are all lazy people, right? Rather than lazy, or it's all about smartness, right? So once a program or once a logic becomes too big or too complicated to be done, let's say in some 2 or 3 spouts and bolts, typically you would like to have a higher level of abstraction. That higher level of abstraction is in the trident thing. So using trident, your programming becomes a bit more concise, right? So that kind of you know, hands-on other things will follow from module 3 and 4, and then module 5 and 6 typically would be the projects based on module 3 and module 4. So those are some of the things which we typically cover in the class. Okay, and then before I start on any questions, so Prashant, I hope it is a problem at your end wherein you are not able to hear me. I hope others are able to hear me, right? I hope others are. That's great. That's great. Sure. So now there are a lot of questions. I don't think I would be able to take all of them. Do post them on the you know, our Twitter handle, but I would like to see as some sort of are there some questions which I can answer right away. So which one is the best in Storm, ActiveMQ or Kafka? Subha, it completely depends upon the use case. Typically I typically prefer to, if you know, the business allows me, I would like to integrate it with Kafka. Subha. Okay, will you guys be teaching programming in Storm? Exactly. So Akash, I hope you have got the answer for your question, right? Definitely programming in Storm, and we'll be covering Java examples for it. Spout and bolt in supervisor node. Yes, yes, Pari, you are correct. Okay. Is there any limitation about the data size in Storm in real time to process? So Prashant, as you can see that it's all about streaming data. You are not going to persist it in the spouts or bolts. So so there is no size limitation as such, right? So how much of Java is required for Storm? Will Trident suffice? Uh, uh, so probably are you saying no? Even with Trident also, Trident is not like Pig. I mean, it's the abstraction in that way it is similar to Pig, but when it comes to Trident coding also it is completely in Java. Okay, Python definitely can be used, yes, for sure, but we are not going to cover Python. Okay, topology is like your MapReduce program. Topology is typically like your, you know, MapReduce main program, driver class. Okay, so guys, I think let me just quickly get started with the quiz because I know that, you know, there is a limited time available here and we are already kind of more than, you know, 1 hour into this. So quickly, Storm can be used in A, B and C. Which one? So Dashrath, you can typically use commodity hardware. Though it is suggested to have an enterprise level hardware, let's say for Nimbus. Great. So yes, answers are quite good. Real-time processing. Annie is typical, our typical character, which those people who have attended some earlier trainings can see that she keeps appearing, and I like her. So, okay, next. Which of them can be a source of stream? Very good. Great. So guys, whomsoever has said A, spout, are wrong. Right, they are wrong. As you can see that they were ingesting the data, but have you forgotten that your bolts were transforming or probably performing some sort of calculations and then passing it over again, right? So all those people who have said A, you can see the googly, right? So this time Annie has not asked such a simple question, though it was simple, but still. I hope it is helping in some way. You people are finding it interesting. It is not possible to run Storm process along with MapReduce jobs inside a Hadoop cluster. This is a very simple question which she has asked. True or false? Very good. So when you say about false, yes, but it comes with a rider that only in Hadoop 2.0 it is possible. It is not possible in Hadoop 1.0. Nimbus node is similar to task tracker node in Hadoop cluster. Somebody had asked me a question like this. Very good. Very good. So I am like a bit surprised that why you people are comparing with the task trackers. There are very few answers which are saying it is false. It is equal to job tracker. I think Akash has answered in the same way, which is very good. And there are others also, right? So it is definitely not task tracker. Probably task tracker at a remote resemblance can be the supervisor, those actual workers, right? Storm topology is defined in the terms of, now this is something where this is interesting. I want to see your responses, A, B, C or D. Nimbus zookeeper supervisor nodes, spouts or bolts, Nimbus zookeeper and supervisor nodes, or spout, bolts and zookeeper node. Very good. Very good. That's great. So let's see the correct answer. It's only spouts and bolts. No zookeeper nodes and all. They're not the part of topology. They're the part of architecture, right? So don't underestimate Annie. She keeps giving some simple questions, but then when she gives googly, right, you have to be really careful. So I hope at least those people who are attending it for the first time, I don't know if there are, they might be finding some value out of it, right? And definitely it's kind of, you know, this is how our sessions are typically arranged. This is how we typically go about it. Okay. And of course, so questions are something which I tried answering every time. So, you know, again, these are kind of recapitulation. These are some of the course fee details which are there. And good thing is if there are some existing Edureka customers, definitely, you know, there is 20% off for those people. And again, these are the, you know, batch detail timings which are there, right? So guys, I hope you found it quite interesting. So Dashrath, as part of, you know, in the professional this thing confidentiality and all, due to those reasons I'm not really able to share those details right now. But yes, over the period of time when, you know, with batch and all, I definitely within the batch I do share it. Once, you know, those things are over, typically I share my details. Okay. Will the deck and the recording will be shared? Yes, they would be uploaded. They definitely would be uploaded in Edureka blogs and they would be sent. So please do visit them. Definitely they are going to be useful. So guys, I hope I would like to probably, if somebody wants to give a kind of a feedback right away, probably yes, you can type in. I hope you liked it and it helped you in some way, though it would not be a just thing to assume that it has helped you in all the ways, right? But at least to give a head start, to give what exactly are the things which you are trying to solve via Storm. That was the whole objective of this webinar. So I hope with this, you know, you enjoyed it, and thanks for attending it. And do post your queries there. Okay. So logging off now. Thank you again for attending it. Good evening, guys. Okay, good night, guys.